We're going to go ahead and just review a couple concepts that you've been working with on force and motion. First, start by examining the pictures below. What types of motion are occurring? Pause the video, take a second to think. All right, did you say that the car is straight line motion? So is the bowler. The people enjoying the ride at the fair are participating in circular motion. And of course, the football being kicked, that is projectile motion. There is not an example of vibrational motion, and that would be like playing a musical instrument. What two factors affect gravity? Well, we learned before that the distance between two objects, for example, the distance between the moon and the earth, affect the gravitational pull. We also know that the size of the object affects gravitational pull. Think about how much you would weigh on the moon versus the earth. Due to the moon's smaller size, you're going to have less weight because there's less gravitational pull. On the earth, you have more gravitational pull, therefore you have more weight. We also learned about balanced and unbalanced forces. There are 4 pictures on the slide. Take a second, pause the video, and discuss which ones do you think are balanced and which ones are unbalanced. All right, if you said the top 2 pictures are both balanced, you are correct. There are equal forces being applied and the net force is 0, therefore the objects aren't moving. Just like the stools balancing on each other, they're equal force, therefore the net force is 0. At the bottom, you have 2 kids, each applying 450 newtons of force. Well, that's equal force, but the kid that's just standing there is applying more force, therefore he is not moving even though the forces are unbalanced. Look at these pictures. Which ones are balanced and unbalanced? Which of these pictures are balanced and which are unbalanced? Take a second to think about each one. The picture on the left of the cart, there's 3 newtons being pulled west, and there are 8 newtons working together to be pulled east. If you kind of think of the examples in the worksheets that we did before, you would realize the net force is 4 east, and the forces are unbalanced. The car would be moving. The kid kicking the ball is also showing unbalanced forces. The ball is in motion. The 2 balloons in the center, balloon A, there's equal forces, and balloon B, there's not equal forces. They're unbalanced, therefore the balloon is moving. The 2 pictures dealing with the car shows you're driving down the highway on the bottom picture and your speed is 190 miles per hour. Hopefully you are on a racetrack and really not on the highway. This is not balanced forces. You are not going at a constant speed. But when you set the cruise control, however, you are going at a constant speed, so therefore it would be a balanced force. Which factors affect friction? I think from the example with the sandpaper, when you pulled the block up the ramp, you notice that the rougher surfaces are going to have higher effects of friction. Look at the 2 other examples and see if this makes sense to you. Okay, for today's lesson, you're going to go on to a website, and it's linked on our Spring Garden page, but there's a link at the top just in case, and it should be a live link. You should be able to click on that and go there. You're going to be using a PhET on projectile motion. For this PhET, you're going to need your notebook, and you're going to do a couple of different things using the PhET. So if you notice, you're going to be shooting things out of a cannon. When you start the first set of trials, I want you to use the settings that are on the left. Make sure you choose user choice, an 80-degree angle. Initial speed is 18 meters per second with a 2 kilogram mass, and then the diameter is going to be 0.1. Click the air resistance button and your drag coefficient is 1. It's basically going to describe how much friction is acting upon that object as it's falling through the air. In your notebook, create a data table looking similar to the one below. Be sure to record at least 5 different masses, and you need to record multiple trials for each mass. When you're finished, you're going to change the settings, and you're going to figure out how air resistance affects the distance. Again, look at the settings on the screen, and you're going to do multiple trials for each. Go ahead and play with the PhET. What other testable questions can you come up with? Collect another set of data and share that in your notebook. The second PhET I want you to work through is on the basics of force and motion. There are 4 different tabs: net force, motion, friction, and acceleration. I would like for you to take about 10 minutes for each simulation and record what you learned from it in your notebook. Make sure you title each section with the appropriate heading. For example, you might say net force and then write everything you learned from that simulation. Then go to motion and do the same. I'll see you guys Monday. Hope you had a great day.